Hey everybody, so in this video we're going to still talk about 5.3, but we're actually going to start graphing using our base graphs and transformations. Okay, so the first thing we're going to look at is translation. Okay, so what translation is moving the graph. Okay, so the first thing that we can see is what if we add or subtract a number? Okay, so we're going to have our base graph, f. So this could be any of the 7 base graphs that we talked about. Now, if we take that base graph and we add a number, okay, a positive number specifically, okay, we talked about this with the parabola. This will move the graph up. Okay. If we subtract a number, okay, this will move the graph down. Okay. Now, if we do this inside of our function, right, this is outside of the base function, okay? If we do it inside the base function, it will affect the x coordinates, right? So outside the base function, it's affecting the y coordinates, moving it up and down. Inside the function, it's going to affect the x coordinates and move it back and forth, okay? So this is going to move it left A, okay? Now I know it seems like positive should move right, but remember from talking about the parabola, right? When it's inside the square, the sign is the opposite of what you think. Okay, so this is actually going to move it left, where if you subtract a number, that's going to move it right. Okay, and we saw this with the vertex form, actually. Okay, all right. So let's look at an example. Okay, so we're going to graph using base graphs and transformations. Okay. So the first thing we're going to do is say what the base graph is, and then we're going to say how the graph is transformed. Okay, so here we can see that the base graph is y equals x squared. Okay, and then we know that this plus 1 is going to move the graph up 1. Okay, so here's our base graph and here's our transformation. Okay, so let's go ahead and look at a graph. Okay, and I will go ahead and draw in the base graph in black just so that we have something for reference. Okay, you don't always have to do this, but I don't want to flip back and forth between the page that has the base graphs. Okay, so here's my base graph with my 3 key points marked. Okay, so I'm going to take all of my key points and move them up 1. So I'm moving this one up 1. Okay, I move this one up 1, and I'm moving this one up 1. Okay, and this gives me my new graph. Okay, same shape, same size, just moved up 1. Okay, all right, let's look at another example. Okay, so we have y equals absolute value x minus 2. Okay, so our base graph, right, you're just choosing from a list of those 7 functions. Okay, so the one that this is most like is the absolute value. So our base graph is going to be y equals absolute value x. Okay, and this minus 2 here, this is going to move the graph down 2. Okay, so let's look at what our graph will look like. Okay, so again, I'm going to draw in the base graph so that we're not flipping back and forth between 2 different pages. Okay, so here's my base graph. This is a sharp V-shaped graph, right? Which is different from the parabola graph, which is a U shape, right? No point at the bottom. This one is a pointy graph. Okay, so I'm going to move all of my key points down 2. So I'm going to move this down 1, 2. Move this down 1, 2. Move this down 1, 2. Okay, and then we're going to draw the exact same V shape. Okay, so there's my graph. You can see same size, same shape, move down. Okay, so those are the 2 x transformations that we were talking, or the y transformations, right? One moves it up, one moves it down. And you can see that they are outside the base function. So here's the base function, and then this is outside. Here's the base function, and then this is just outside of that. Okay. Let's look at some more translations. They are transformations, but they're more specifically translations. Okay. So we'll have y equals the square root of x minus 1. Okay. So the first thing we're going to say is, what base graph is this? Okay. So this is the base graph that is y equals root x. Okay. And then what does this minus 1 do? Okay, so first of all, we can see it's inside the square root. Okay, so that means it's going to affect x coordinates. It's going to move left and right. So this minus 1 is going to move it right 1. Okay, it doesn't move it down because it's inside the main function, which is the square root. Okay, so let's look at how the graph would look. Okay, again, we'll do our base graph in black, and then we'll do our transformation in bright green. Okay, so our base graph, the square root graph, 1, 2, 3, 4, up 2. Okay, so here's our base graph. Remember, this is one of the unusual ones where the key points aren't just -1, 0, and 1. Okay, so it's 0, 1, and then 4, 2. Okay, so we are going to move this right 1. So I'm going to take all of my key points and move them right 1. So this one's going to move here. This one's going to move here. And this one will move here. Okay, and then I'm going to draw it in. Same shape, same size, just shifted to the right. Okay. Let's look at one more translation. Okay. Okay, so the first thing we have to decide is, what base graph are we going to use? Okay, so this looks like 1 over x squared. Okay. Right, we can tell it's a fraction, so it's either going to be 1 over x or 1 over x squared, and because it has the square, we pick 1 over x squared. Okay. Now this plus 3 is inside the function, right? Outside the function would be way over here. Okay. So this is inside the function, so that's going to move it left or right. Okay. Plus 3, that's going to move it left 3. Okay. Remember, when you're moving left and right, plus goes left, minus goes right. Okay. So let's look at what a graph would look like here. Okay. So I'll draw my base graph. Okay. So my base graph has those key points. Okay. And remember, the key features are these lines here. Okay. The graphs don't go across those lines, so they really give you a good sense of the shape. Okay. So now my transformation was right 3. Okay, so I'm going to move my whole graph right 3. Okay, so I'll take this key point, move it right 3. 1, 2, 3. I'm going to take my other key point and move it right 3. 1, 2, 3. Okay, and the lines also move right 3. So I'll take this vertical line and move it right 1, 2, 3. Okay, and I'm going to dot in this vertical line. Okay, and I'm going to do the same thing with my horizontal line. So I'll just move it right 3. Okay, it still looks like a horizontal line, so I'm still going to dot it in here. Okay, and remember, the graphs don't go across that line, so it gives you a good sense of the shape. Okay, draw in that corner shape. Okay, like this. All right. So remember, when you're doing the transformations with these ones that have the horizontal and vertical lines, the transformations do affect those. Okay, let's look at our second type of transformation. Okay, now this is something that we've also already seen when we talk about parabolas. Okay. Okay, so we're going to talk about reflection, which flips the graph. Okay, so we're going to start with our base graph. Okay, and there's only 2 types of reflections. You have one that is outside. Okay, anything that's outside the function reflects or affects the y coordinates. Okay, so it's going to affect up and down. It's going to flip it down. Okay, so this okay, it reflects it up and down. Okay, which is reflects across, okay, the x-axis. That's another way of saying that it's flipping it downwards. Okay. Now, if it's inside the function, like this, okay, that's going to affect the x coordinates, so it's going to flip it left to right. Okay, which you can also say reflects across the y-axis. Okay, so let's look at some examples of this. Okay, so the first one we're going to do, we will use the x squared graph, okay, because we're familiar with graphing those using transformations. Okay, so like I just said, our base graph is going to be y equals x squared. Okay, And this minus sign is outside of the square. Okay, the base function is the squaring function. So this is out front of the squaring part. Okay, so this is going to reflect up and down, which is across the x-axis. Okay, so let's look at a graph. Okay, so what is this going to look like? So I'm going to dot in my key points here and draw my base graph. Okay, so this reflects across the x-axis, right? Meaning it's going to go from up here reflected down here. Okay, so when I reflect this point, it's going to reflect down here, right? I'm reflecting across this line. This is on the line of reflection, so it doesn't move at all. Okay, this is going to reflect from up here to down there. Okay, and now it is going to be upside down, right? Because it's reflected. Okay, so we've seen this example of reflection before, okay, but just a reminder of how to graph that using the transformations. Okay, so let's look at another example of graphing using reflection. Okay, so we're going to use square root of negative x. Okay, so our base graph is root x, right? Square root of x. And then we can see that inside the square root, meaning it's going to affect the x coordinates, okay, is the minus. So it's inside, so this is going to reflect across the y-axis. Okay, so let's look at what our graph will look like. Okay. Okay, 1, 2, 3, 4. Okay, so our key points for our base graph are 0, 0, 1, 1, and 4, 2. Okay, so here's our base graph. Okay, so I'm going to reflect them all across this way. So because this is on the line of reflection, it stays there. Reflect this across and reflect this across. Okay, connect them with the base graph shape. Okay, and you can see it is reflected across this way. Okay. All right. So let's talk about our last type of transformation. Okay. And this is the one that I think gives the students the most trouble. Okay, so we're going to be extra careful and practice more of these. Okay. Okay, I guess the technical name for these, I should say, is scaling. Okay, so what scaling does is stretch or shrink the graph. Okay. All right. So again, we're going to have our base graph. Okay. And we're going to have a number that is positive. Okay. Okay. So when you have a multiple, and we saw this with the parabolas, it affects the y coordinates of the key points. Okay, so this multiplies the y coordinates of the key points by a. Okay, So for example, if you had the point 1, 1, okay, it would be 1, same x value, okay, and now you would multiply 1 times a is a, okay, so it changes just the y coordinates of the key points, okay. Now if a is a number greater than 1, like 2, this is going to stretch out the graph vertically so it's taller and thinner. If this is less than 1, right, it's going to make the y coordinates smaller, the graph is going to be shorter and wider, okay. So let's see an example of that. Okay, so we're going to graph using base graphs and transformations. So the first one, as we've been doing, we're going to go ahead and use the y equals x squared base graph, okay, because we're familiar with this example. So the base graph, like I just said, is y equals x squared, okay, and the transformation is that it's stretched times 2, okay. So my old key points, remember, were -1, 1, 0, 0, and 1, 1. Okay, so when I stretch it, my x coordinates are all going to be the same. Doesn't affect the x coordinates at all. Okay, and the y coordinates are going to be multiplied by 2. So 1 times 2 is 2, 0 times 2 is 0, 1 times 2 is 2. Okay, so let's look at our graph. Okay, so my base graph here, okay, and then I'm going to mark my new key points. I actually had them written down. So it was -1, 2, 0, 0, 1, 2. Oops. Try to make that a little more U-shaped and a little less V-shaped. There we go. Now you can see exactly how we saw in the previous chapter when we were talking about graphing parabolas, that this is taller and thinner than the base graph. Okay. Let's look at a couple more for this one. Okay. Again, I think this is the transformation that causes the most trouble, so we're going to do some extra examples. Okay. So let's look at something like 1/2 times absolute value x. Okay. Now my base graph, I see absolute value x, so my base graph is going to be y equals absolute value x. Okay, and I see this times 1/2, so this is going to shrink it, right, to 1/2 its size. Okay, so I'm going to start with my key points, which were -1, 1, 0, 0, and 1, 1. Okay, and I'm going to affect all of my y coordinates and make them half as much. So my x coordinate's exactly the same. My y coordinate is half. 1/2 times 1 is 1/2. Okay. My x coordinate's exactly the same. My y coordinate is 0, is half of 0. Half of 0 is still 0. Okay. Here, my x coordinate's exactly the same. My y coordinate is half. Half of 1 is 1/2. Okay, so these are going to be my new key points, right? X coordinates exactly the same, y coordinates are half. Okay, so let's look at our graph here. Okay, so we'll draw in our base graph. Okay, like that. Okay, and now we're going to draw in our transformation using those key points. So -1, 1/2, 0, 0, 1, 1/2. Okay. So you can see the V shape is much wider, right, and shorter than the original graph. Okay. All right. So I want to do probably the most complicated examples. Okay. Okay. So the way that I want to think about this, okay, is I want to think about this as 3 times 1 over x. Okay, these two are equal, right? That's how you multiply a whole number with a fraction. Okay, but this gives me some information about the base graph and the transformation. So this tells me that my base graph is going to be 1 over x. Okay, and my transformation is going to be times 3. Okay, so remember my key points used to be, okay, -1, -1, and 1, 1. Okay, so this isn't going to affect the x coordinate at all. Okay, and the y coordinates are going to be times 3. So -1 times 3 is -3. 1 times 3 is 3. Okay, so these are my new key points. So let's look at my graph. Okay. So I'm going to draw in my base graph. Okay. Okay, I'm actually going to draw my new graph right next to it. Okay, so that we can compare. Okay, so I'm actually going to draw in my horizontal and vertical lines. Okay, and then I'm going to draw in my new key points. So I had -1, -3. Okay, and then I had 1, 3. Okay. The graph still goes along these horizontal and vertical lines. So you're still going to draw your graph going towards these lines. Okay, it doesn't stop higher up just because this point is higher up. Because these lines are in the same place, the graph has to go towards them. Okay, so you can see here the comparison between the base graph and the transformation. Okay. All right, let's do one more like that. Okay, so again, I want you to think about this as 1/2 times 1 over x. Okay, here's our base graph part. Here's our number times that. Okay, so my base graph is going to be y equals 1 over x. Okay, and my transformation is going to be the 1/2. So it's going to be shrink, right, times 1/2. Okay, so my old key points, again, were -1, -1, and 1, 1. Okay, so my new key points are going to have the same x coordinate and half of the y coordinate. Okay, same x coordinate, half of the y coordinate. Okay. So let's look at what the graph would look like. Okay. So we'll do side by side of base graph and transformation again. Okay. So my base graph has these key points, okay, and these key features. Okay. And I know that my base graph has this shape. Okay, so let's look at the transformation. Okay, so again, I'm going to draw in my key features, which is those two vertical lines. Or the vertical and the horizontal line. Okay, and then I'm going to put my key points. So it was -1, -1/2, right? And then it was 1, 1/2. Okay, and my graph still has to go along the lines. I'm going to draw it going towards the lines here and here. Here and there. Okay. Now the graph looks super similar. The only difference is that these are a little bit closer to the axes than these ones, okay, right? It's like squished down towards the center, okay? And that's exactly what you should see with the shrink, is that it's squeezed down this way, okay? All right. I hope that makes sense to you guys. There will be another video on graphing using transformations, and there'll be next time, not for this class, but for the next class, a video about graphing using multiple transformations. Okay, I will see you guys soon.